example 8, least common multiple over least common multiple. This works well when you have complex or compound fractions. So if you plug in 0, you get 1 half minus 1 half over 0, which is 0 over 0, we know there's a problem. Okay, it might be easier to write it like this. Alright, well, if my pen decides to work, okay, it's easier to see what the least common multiple would be of all the denominators. So we're going to multiply the top and the bottom by this term. Okay, that'll clear all of the denominators from our problem. So I'm going to go ahead and just put that down here. Alright, this is one. This has a limit here. Great. So we have the top we end up with 2 minus the quantity 2 plus x. At the bottom we get x times 2 plus x. And if we distribute the top, we have the limit because x approaches 0. 2 minus 2 minus x. Here we have this 2 plus x. Now plug in our 0. Negative 1 over 2 times 2 plus 0, or 2 times 2. Which one isn't so bad? A little bit of space. Alright, so this one looks like we're going to multiply the top and the bottom by 6 times the quantity. Oops, x minus 6. Yep, I can't write it apparently, so. Oh, this is lovely. Okay, so multiply across the top and the bottom. So at the top we have 6x times the quantity, x minus 6. And on the bottom, we get x minus 6 plus 6. As you can see, the minus 6 and plus 6 will cancel out. The x's will cancel out. You plug in your 0, 6 times negative 6 gives you negative 36. Again, not so bad. Here, sledgehammer, cool name, right? You plug in 0, you're gonna get the. We're gonna always get a problem with these. And this means something really big, but I can't tell you what it means yet. With the sledgehammer method, you just need a lot of space. My computer doesn't want to write limit. Maybe it's afraid to do this one. It's not so hard. So multiply everything out. Things cancel. Oh, look, x squared minus x squared. Factor out the h in the numerator. Cross it out with the one in the denominator. Plug in 0 for h. We get 2x. I know it's not a number. You wanted a number, but it's a function, and that's good enough. Okay, for part B, I'm going to write it down in the bottom just because I don't have enough space up there. I want you to be able to see it. It's going to work really well if they don't disappear as I write it, but I think that could be anything. Minus 2x minus 2h. Oh, the minus 1 all over h. And again, it's good to write it out very carefully. Don't forget the terms. Look at what you can cancel out. Everything has an h left. So take your limit of to 0, factor from h. We have 2x plus h minus 2h. For h, cancel those out. Plug in 0 for h. We get, cross that one out, sorry. We get 2x minus 2. Another function. I wonder what this could mean. You have to wait till we get to our interpreter section. Alright, and now it's time for singular salta. Look that up. Okay, I think it means jump or jumps. So this graph, f of x equals absolute value of x over x, or vice versa. It's a piecewise function. We're going to use the graph to help us figure out these limits. Okay, the graph is just like this. Except for 0, pretty exciting graph, right? So you're running along -1, you jump up to 1. So you want to break it down into a piecewise function. It will be +1 when x is greater than 0, or -1 when x is less than 0. Okay, at x equals 0, it can't be because we have 0 to 0, we know that's a problem. So looking at our graph, evaluate the limit as x approaches 0 from the left, -1. As x approaches 0 from the right, 1. As x approaches 0, that means from both sides, does not exist. It's going to two different numbers. And now as x approaches 3, well, it looks like it'd be about here. Okay, plug it in. 3 over 3, that's 1. Done. Okay, now these, just a little bit different than that senior salsa. So if I factor this out, limits x approaches, limits, x approaches 5 to the left, we get 2. If I pull out that x minus or the 2, it's not going to change the value. Okay, and now what we can think about this is just like that graph. It just moved over to the right 5. It's going to be at -1, that is at -2 and 2. So we're going to pull that 5. And again, instead of being -1, it's -2 and 2. So as we approach 5 from the left side, we have -2. As we approach 5 from the right side, we get 2. As we approach 5 from both sides, we get does not exist. Alright, so you kind of have to break these apart separately. So let's see. This one. We can look at this separately. We have x squared on top. I'm going to put the 2 out there. I'm going to factor this out, and I get x plus 3. I bet on the bottom we can factor something out, 4, and end up with x plus 3. So I'm going to look at these two separate functions. Reduce this, make that a 2. So limits x approaches -3 from the left, x squared over 2. Now we have it over 2. And now I just have to determine on the left side of this graph, is it negative, or is it 1? So imagine to do this. Left 3, so on the left side, it's -9/2. Okay, let's try this again. I thought we can factor numerator. And if you're not sure what we should factor it into, take a look at the bottom, what that factors into. And that factors into x minus 6. So I bet you can put an x minus 6 term. And I think that's the being x minus 2. So plug in 6. 6 minus 2 over 2. So it'll be 4 over 2 over 2. And now we just have to look at this to determine is it the left side or is it the right side. So pick a number on the right side of 6. That would be 7. Plug in 7. 7 minus 6 is 1. 7 minus 6 absolute values. So we get +2. All right, and this last one we're going to do a similar idea. We're going to take the limit as x approaches 7. Sine of x. 3 times sine of x. I'm going to factor that out. I get x minus 7. In the bottom, I can factor this into x plus 7, x minus 7. Plug in 7, so we get 3 sine of 7 over 14. Now, is it going to be positive or negative? Neither, right? Because we're not going from the left or the right. We know there's a jump there. So actually, this does not exist. And now onto our last problem for today. So this is an important thing to read. Basically, you're going to need three things in calculus to help you out. One of three things, anyway. A calculator, a smart, helpful friend, or a couple of trig limits memorized. That'll make everything else in this class easier. So figure out what you want, but it's going to be really helpful to memorize this. So what I'd like you to do is, with your calculator, if you need to do it with a table or maybe with the graph, whatever, evaluate these two things. These are so important, and they'll be a vital part of our next video of this section.